Number 2, base of the solid region. Between the curve y equals 4 times cosine x. And the x-axis from x equals 0 to x equals pi over 2. The cross sections perpendicular to the x-axis are squares. So we know we're perpendicular to the x-axis and we have squares. And instructions say all we have to do is figure out the area. So now, what's the area of a square? S squared. So all we have to do is figure out what the length of the side's going to be, and then square it, and we're good to go. So now, if we're going from 0 to 2 pi, or pi over 2, and we have y equals 4 times the cosine of x. The way that I always think about it is, if we look at the unit circle, what's the x value here at 0? 1. What's the x value here? 0. And the x's always correspond to the cosine values. So if the cosine at 0 is 1, and the equation is 4 times the cosine, it'd be 4 times 1. So we're way up here at 4. And then it goes all the way down here. So this is the cross section, or not the cross section, but this is that footprint. This is the base of the shape. Now, we're going to draw squares that are going to come straight up here. So the cross sections perpendicular to the x-axis are squares with diagonals running from the x-axis to the curve. So this isn't actually the side of a square. This is the diagonal of a square. So
the square would go from the origin to pi over 2.
not necessarily.
So there's no 45 then.
Oh yeah, it's absolutely a 45, 45. So this would be like x times the square root of 2. So that's your 45, 45, 90. Now here, that's 4 times the cosine of x, correct? And so what's the length here?
Wait, how do we know it's 4 times 4 cosine of x?
Because that's the equation that we have. So we know that's the diagonal. So the diagonal, x times the square root of 2, is equal to 4 times the cosine x. Now, we'll say this. We'll call that A instead. Or you could have called it S for side. But A times the square root of 2 is equal to 4 times the cosine of x. So if I divide that by the square root of 2, divide that by the square root of 2, A is equal to 4 times the cosine of x over the square root of 2. And I gotta zoom that out a little bit. Now, is that the side? Okay, I got the side. So now what do we have to do? Square it. So area is going to be my a squared, which will be 4 over the square root of 2 times the cosine of x. That quantity squared. So that'll be 16 over 2 times the cosine squared of x, which is 8 times the cosine squared of x, which would be C. Now, the trick was the fact that it said that these were the diagonals of a square and not actually the side of a square. So this is kind of a weird shape, because then you have half of the square below it and half of the square above it. So it'll end up being probably a cool looking shape, but honestly, I don't care what the shape looks like. I just care about how I'm going to figure out the area of it. So use the idea of, if they ask about diagonals and all that, chances are I'm not gonna, because honestly, I've never seen anything on any of the multiple choice type things, but it's nice to see every once in a while. Does that make sense how to figure that out? And the key to that is recognizing that it was a diagonal. In third hour, I told him just to ignore it and just go for the side squared. And if you just went, and this was your side squared, you'd end up with b, 16 times the cosine squared of x. That would be if you just said that's the side of a square and the square comes up like that. But since it's the diagonal, I'll have to tell them that tomorrow. They'll be unhappy with me. You know how much sleep I'll lose over that? None. I'll just lose my normal amount of sleep. All right, number 9. Number 9 says that we're going to rotate around the x-axis. Because basically everything here is rotating around the x-axis. Now we have a bunch of different equations, so we have to figure out basically what's going on here. So if I go 1, 2, 3, 4, 5, the first equation, y equals 5, is right here. Y equals 5. And remember, here's the x-axis. No, that's the x-axis. And then we have 5x, and it's going to go through the origin. It has a slope of 5, so I could go, if that's 1, that's 2, that's 3. 1, 2, 3, 4, 5, 1. It's going to go here. Now, where is it intersecting? What's the region that I'm going to rotate around? Well, I'm going from 0 to 1. So, here. All right, so I'm going from 0 to 1, and if I draw this a little bit bigger to make it look, to make it easier on us, that's from 0, that's to 1, that's y equals 5, this is y equals 5x. Here's my representative rectangle. Now, since we're rotating around the x-axis, we ask ourselves, is there space between the axis and the rectangle? All right, so there's space between the axis of rotation and rectangle. And that space is over here. Yeah, that's the same one. That's the same. That's this triangle drawn at a different scale to make it easier for us to find big R and little r. That's all I did. Is I just drew it to make it look nicer. Because you can draw it any way that you need to in order to make sure that you get the correct answer out of this. So I have to figure out, first off, big R. And then I got to figure out little r. So big R is here. What's the length of this segment right here? Well, what's this value here? 5. What's this value here? 0. So what's r? 5 minus 0, which is 5. Now what's r squared? 25. Not too bad? All right, now, going for little r. What's this value for little r? 5x. Whenever you hit one of the lines, it's going to be the equation of that line. So in this case, it's 5x. And that's 0, so little r is 5x. So what's little r squared? 25x squared. So what's big R squared minus little r squared? Yeah, 25 minus 25x squared. So I will recommend this to you 100 times out of 100. Find your big R, find your little r, then do the r squared and the r squared and subtract it all out so you have something that we can just throw into the integral. as opposed to trying to do all this inside the integral. Because my integral now is, my volume is going to be pi times the integral from where to where? From 0 to 1. Because we're still rotating around the x-axis, and that point of intersection, where 5 is equal to 5x, divide by 5, x is equal to 1. If you do that, we're going from 0 to 1, 25 minus 25x squared dx. So now it just becomes a pretty straightforward integral. This is going to be pi times, don't forget the pi. What's the, when you integrate 25, what do you get? 25x. Integrate 25x squared, what do you get? 25x cubed over 3. And we're integrating this from 0 to 1. Now, the 0 is nice because the 0 zeroes out everything, so we don't even have to worry about that. So this would be pi times the quantity of 25 minus 25 thirds. Now, if I wanted to just worry about this as far as getting a fraction over 3, you have 25 over 1, so you need 3/4, which is 75 minus 25. So this is what, 50 pi over 3? Yeah, little r is only for the washer method. Or as I like to say, the warsher method. Not sure where that little r comes from in the warsher method. But if you think about it and talk about warshers. Now, remember, ladies and gentlemen, when you're building your diagram, this one, the one that we started off with, would have been really hard to deal with because all of a sudden you're dealing with this, and then you got to find an R and an R, and you see how it's just getting really compact, and it's really hard to see everything. So if we kind of stretch it out a little bit, we can actually get a better picture that's easier to deal with. And as long as everything is working out right, the more that you do that, the easier that these are going to be. Okay, other questions? So you guys are all ready for this? Number 11. All right, number 11. Now, when we're talking about like the square root of 7x, first off, I know that we're going, if we're here, there's 1, 2, 3, 4, 5, 6, 7. There's y equals 7. That's one of the lines we're using. And then we have to figure out, all right, I know we're starting at x equals 0. I got to figure out where that x is where they intersect. So what we need to do right off the bat is say y is equal to y. So the square root of 7x is equal to 7. Just by taking the two equations, setting them equal to each other, so we can find the points of intersection. Now square both sides. So 49 is equal to 7x. So divide by 7. So x is equal to what? 7. So at 7, they're going to hit each other. Now at 0, what's the value of y? The first y. You plug in a 0, what's the square root of 7 times 0? 0. So I'm pretty sure it's going to do something like this. Because you should know that the graph of the square root of x kind of does this. Now, we're rotating, again, around the x-axis. There's my rectangle. The directions say rotate around the x-axis. And those are the directions in front of number 3, and they don't change. All right, number 5. At the top of number 5. Now, I got to figure out big R. Big R goes all the way up to where y is equal to 7. So what's the length of R, big R? R. So R squared is 49. Now, little r is going to what point here? Square root of 7x. And since they're both 0, little r, that's square root of 7x minus 0, square root of 7x. And so r squared, little r squared, is just going to be 7x. That's this graph right here. And our rectangle is always going to go from one graph to the other graph. So whenever we go up to that, to one of the graphs that one of the lines that we've graphed, this one is where y equals 7. So that's y equals 7. And this one is y equals square root of 7x. So that's why we hit that one. So big R squared minus little r squared is equal to 49 minus 7x. So my volume, pi times the integral. Now, what are my x bounds? 0 to 7. 49 minus 7x dx. Integrate, you get, what, 49 and we are going to go from 7 to 0. Now, does 0 play a part? Not at all. So I need 49 times 7. I'm going to say that's 343. Because that'd be 7 cubed, wouldn't it? And here's 7 cubed, so it's minus 343 over 2. So this is going to be pi times, I want to put this over to 686 minus 343 over 2. Isn't that just going to be 343 pi over 2? I hope that's one of the answers. Yeah, that would be D. Nope. It's just discs and washers. Cross sections, discs, and washers. If you get 6 of them, it'd be 2, 2, and 2. If you get 9 of them, it'd be 3, 3, and 3. Any other questions?